Well, tangents are derived from which two trig functions? Sines and cosines. So this becomes the sine. We'll just do alpha plus. We're going to do the sum over the cosine. And then we know what the sum of a cosine is. So we know that's sine, cosine, cosine, sine. And we know what the sum of a cosine is. That's cosine, cosine, sine, sine. But it's opposite sign value-wise. So just from what we did on Thursday, we can come up to that. And then here's where I want to eliminate one of these products. A sine, cosine, alpha, beta product, a cosine, cosine, alpha, beta product, a cosine, sine, alpha, beta product. I'm going to get rid of this. One right here. And the way we're going to do that, I'm not really going to get rid of it. I'm just going to make it become a 1. We're going to divide all of those products, each of those, by a cosine alpha and a cosine beta. So that's what we're going to do. And it comes up to this. Sine alpha, cosine beta. And then those are each going to get divided by the cosine alpha, cosine beta. We're going to do the same thing with the denominator. You're going to see some things going to be able to cancel for each of these. So we eliminate, or we simplify this. So the first product, we get cosine betas to disappear, and we just get a sine over cosine, which is a what? Tangent, right? Cosine alpha, and again, leaving you with a sine over cosine, another tangent value there. And then these two are the same, they become just 1. And then over there, you've got 2 tangents. One of them's an alpha tangent, one of them's a beta tangent. So all of this simplifies to what we have down here. So there is the tangent of alpha, and there's the tangent of beta. And here's the 1. And over there we have tan alpha, tan beta. Now you'll notice the sign, S-I-G-N, and if this is plus, if we're adding the angles, it stays positive on the top, and it becomes the opposite in the denominator. And then that's the reverse of subtraction. So now we have 6 formulas we're going to need to know. Some differences of sine, some differences of cosine, and now these two, some differences of tangents. There's a little more work involved with these problems because oftentimes we end up with something that needs to be rationalized, or we end up with a conjugate pair that we have to use, because I don't want to end up with a denominator that has a radical in the bottom. That does happen for sines and cosines as well, but we just didn't see any in the last, well, this example problems-wise, we didn't see anything. They were probably in the homework. All right, so they should be on your flashcards or your formula sheet or whatever it is that you guys are doing to figure out memorizing all these formulas. By the time we're done with all this stuff, right now we have 6, and we have double angles that we're still going to do. I think we're going to have like 11 of them, 10 or so, by the time we're all done with this stuff. All right? Got that down? All right, let's go do these. See how simple they are. Tan of 195. Now, how many of you, when you were doing the sine and cosine problems. Were any of you thinking of, like in this example here, tan of 195? Was anyone thinking in regards to a reference angle that puts you in a certain quadrant for that? Meaning, tan of 195 would be a 15-degree reference angle in quadrant 3. Was anyone doing that kind of thing? Good, because we actually, that could get us in trouble, but just think specifically about reference angles. I could end up in a place quadrant-wise where my answer is supposed to be negative, but because I chose a reference angle and it would say a 60-degree reference angle, I was in the wrong quadrant. I put a positive value. So I want you to take these angles, whatever they are, and use our 30, 60, 90 angle references to create the 195. I don't want that to become a 15-degree reference angle, and then you're saying 15, no, 45 minus 30. That's how I get this. So I don't want you. Right? So 195. Two different ways. Let's do it with a sum. How are we going to do this? By adding angles together. 135 and 60, that would work. There's a couple of them that do, that one will work. How about difference? How are we going to get that over here? Hmm. 225 and 30, yeah. What's up, Julius? Were you just giving me the answer?
Yes.
Okay. All right, so addition, subtraction, we should get the same thing. Let's set up our rule. So here's our alpha, here's our beta. This one we'll set up as the tan of alpha plus the tan of beta over 1 minus the tan of alpha, the tan of beta. This case is 135 and 60. Over on the other side, it would set up as tan of 225 minus tan of 30, 1 plus and then we'll go from there. So we're going to just work on the left side. Same thing. Same answer. Tan of 135, who knows that? Negative 1. I'm in quadrant number 2, where tangents are negative, 45-degree reference angle, plus tan of 60. Root 3. Root 3 over 1. All right, so there's the numerator, and then we have 1 minus, well, we have the same value. So 1 minus a negative 1 for the tan of 135. Tan of 60 is a root 3. So we can see that I've got some denominators with some radicals in them, so we're going to have to rationalize this. So I get negative 1 plus root 3 all over 1 plus root 3. And then how do we undo or rationalize a binomial difference? Well, okay, you're right. I make it a difference of 2 squares, but I'm using the what? What's that called? The conjugate. I'm going to multiply by the conjugate of a 1 plus, which is a 1 minus a root 3. So now I have difference of 2 squares at the bottom. On the top, I'm going to have to FOIL all these guys out. So we get a negative 1 plus a root 3 plus another root 3 is plus 2 root 3's. And then a square root of 3 times a negative square root of 3 is a negative 3. On the bottom, 1 minus 3. And then simplify everything. We get negative plus 2 root 3 over negative 2. And that has some simplifying to do still. Numerator, I can factor out a negative 2. Pull out a negative 2 and I get a 2 minus a root 3. And then denominator of negative 2, they get to cancel each other out. And we finally get our answer. 2 minus root 3. So these have a little more work involved with them, especially because you have the conjugate. But not difficult. difficult, just being careful, specifically with those negatives on either distributing a negative or multiplying. So there's that. Tan of 195. All right? How about it? Any questions on that one? Tan of 195. So we don't have a rule for cotangents, we don't have a rule for secants, we don't have a rule for cosecants. So what do we need to do instead? Yeah, we need to 1 over them. So there are 2 approaches to this. So first of all, maybe we start with the fact that I've got a cotangent, which is actually 1 over tan of negative 2p. And then here's what I would do. I would, well, we'll set up first of all, how am I going to get that negative 15 out of here? Tan of, I could either, say that again? 30 minus 45 would work. So we're going to go tan of 30. So we're going to go tan of 30 minus the tan of 45. 1 plus tan 30, tan 45. Now, here's what I would do. So I don't lose this 1. I see that I've got a 1 over something going on. A 1 over is also a what? What's the name for that? 1 divided by reciprocal. This is a reciprocal. So what I would rather do, so I don't lose this 1 in the numerator, just take the denominator value right now and just reciprocal that. And start there. So rewrite this then as 1 plus the tan of 30, the tan of 45, all over tan 30 minus the tan of 45. And then go from there. Then you don't have to worry about forgetting about that 1 over thing. You're already reciprocaled right there at that point, and you're ready to roll. All right, I'm going to need you guys to finish that one. See if we get the right answer. As negative 2 minus root 3, you just distribute the negative 2 negatives through. Maybe, where would there be a tricky part? Maybe right here. Like, how did I get that from here? 1 plus a 1 over root 3. I just make common denominators. Root 3 over root 3 plus 1 over root 3, and then simplify it to look like that. And then once you have the same denominators, root 3's, they just cancel each other out after you save, change, flip. And then you have to rationalize. All right, what questions on that one? So this isn't really, the only thing, chapter 10 about this whole thing is the very beginning. That's it. Setting it up with the right rule. The rest of it is just algebra 1. It's all simplified. We good? One more? This one, I'm not going to actually, well, I'll let you guys tackle this one as I'll just put it on the YouTube. How's that? You don't have to do that. We just did this with sine and cosine. It's the same thing that we were just doing with sine and cosine. So I'll put this on. You guys, if you don't have questions on anything right now, just go ahead and get started on it. Yeah, it was the evens, I think, is what I did. Yeah. Whatever the odds were, Thursdays were, the evens for that. Ready for the simple?